Hello, Math 120, and this is Professor Gonzalez, and I'd like to do some homework problems from section 9.1. 9.1 is about learning how to use and remembering the distance formula and the midpoint formula. So let's start with the distance formula. The starting us off, number one says, complete the following sentence. The distance between points, the 2 points p sub 1, x sub 1, y sub 1, and point 2, which is denoted with x sub 2, y sub 2, denoted by p1, p sub 1, comma p sub 2 is, okay, and so what's the formula? The formula is, let's see if I could find it, x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared, and the whole thing is square rooted. So this is going to be d. So the formula for the distance is right here. Okay, and that's not d. D is d means distance, so it's our third option. Okay, so let's see if we can implement that formula right there. Number 2 says find the distance between point p sub 1 and p sub 2. So basically point 1 and point 2. Now I think what I'm going to do is I'm going to go ahead and write down those points right here. It says that point sub 2 is 7 comma 4. I'm pulling this right off of the graph. And then point sub 1 is 1 comma negative 4. Now it really doesn't matter which one you start with, which one you label 1 and 2. What matters is that you stay consistent, meaning once you label, the first one as 1, then it has to consistently be 1 for x and for y. So let me show you what I'm talking about. We're going to go ahead and take the formula, which is the distance between these 2 points is going to be the square root. And now what we're going to do is we're going to take the difference of the x's. So I'm going to go ahead and show that. Let me use, basically the format looks like this. The difference of the x's squared plus the difference of the y's squared. Okay, and so if I say I'm going to start with 7, so the difference of the x's, and I go in this direction, that means that I'm going to have to stay consistent if I now want to take the difference of the y's. I have to still start with this point, right? So it'd have to be 4 minus a negative 4. Now something that you have to be really careful of is sometimes you have a double negative like right there. And we know with a double negative, we can think of that as a positive. All right, well now let's simplify a little bit further. 7 minus 1 gives us 6, and that's squared. Plus 4 plus 4. 4 plus 4 is 8, and that is being squared. And then 6 squared is 36. 8 squared is 64. And then we sum that up. 36 plus 64 is 100. And you know that the distance, so the square root of 100 is 10. So the answer is the distance is 10. Okay, that's using the distance formula. The distance formula, I always say, is a ripoff of the Pythagorean theorem. Let me show you. I can do the same problem. Now, problems will be given to us as just 2 points, and they want to find the distance between those 2 points. So this formula is perfect for that. But let's just kind of get a better understanding of what's going on here. If you take, I'm going to zoom in even further here. If you take a look at this distance, right, the distance is right here, d, the distance between those 2 points, d. We can think of this as a right triangle. And notice it forms a right angle, right? So it's a right triangle. So the question is, what's the distance of that red leg of the triangle? And remember, that is horizontal, so that's just the difference of the x's, really. But we can count it out, and I wish the scaling was better. But anyways, if we start here, we go 1, 2, 3, 4, 5, 6. So that side is 6. And remember, with our formula, we also ended up with 6 right here. Whoops. There we go. We also ended up with a 6 right here, right? Which was one of the sides of that triangle. And if you take a look at the green side of the triangle and count that up, here we'll start here and we go 1, 2, 3, 4, 5, 6, 7, 8. So that side is 8. And if we go back over here and take a look at our formula, well, there's the side of that triangle right there. Okay, so it really is just the Pythagorean theorem. Of course, with the Pythagorean theorem, you would say something like, you'd say, right, it's a squared plus b squared equals c squared. So you'd say 6 squared plus 8 squared, equals d squared, right? That'd be the Pythagorean theorem. And 6 squared is 36, 8 squared is 64, d squared, when you add that up, you get 100. And if you want to solve for d, you square root both sides. And normally when we square root, we say plus or minus, but this is a distance. So, we're not going to have a negative distance, so we just disregard that completely, and we just have the distance is 10 units. That's great and all, but you had to have a picture. You had to look at its sides, realize it's a right triangle, figure out its sides. And this formula sort of does all that for us just by starting with 2 points. Okay, I'm not sure, what is that little sign up there from? What is this little thing? I guess there's a negative there. Somehow it looked like it jumped. I'm not sure if something moved. Anyways, let's go back over here. So the answer to that last problem is 10. Let's do this again. Find the distance between the 2 points. Okay, well, we've got this great formula. It is just going to be the distance equals the square root of, now the difference of the x's, so I'm just going to go in this direction. So it's going to be 12 minus 4, and that gets squared, plus, I'm going to continue, I have to go in the same direction, 9 minus 3 squared. Well, 12 minus 4 is 8 squared. And 9 minus 3 is 6 squared. These numbers are sounding very familiar. And so 8 squared is 64. 6 squared is 36. 64 plus 36 is 100. And the square root of 100 is 10. I guess we're getting the same answer again on this next one. They weren't very clever on different answers. Yeah, and one of these, I think I might as well just do this one. Let me just show you that if you label the first one 0.1 and the second one 0.2, or vice versa, it doesn't matter. I'm just going to do that right now. This problem is done, but let me just do this again with another color, just to show you I can go in the other direction and get the same answer. So if I'm trying to find the distance, and what if I said, okay, I want to go in this direction. I want to say 4 minus 12. Now that, remember, it's a square root. 4 minus 12 squared plus, and then I'd have to, now here's the critical part, you have to go in that same direction, 3 minus 9. 3 minus 9 squared. Now 4 minus 12 gives us a negative 8. And 3 minus 9 gives us a negative 6. And you can now start to see why it doesn't matter if you went in the opposite direction, because a negative 8 squared still gives us positive 64, and a negative 6 squared still gives us a positive 36. So we're still going to get the same exact answer. Okay, so the direction is not important, but it is important to stay consistent. If you went in one direction with the x's, you have to go in that same direction with the y's. That part is very important, otherwise it will not be right. Find the distance between these 2 points. Well, let's do this one. Let's just say, okay, the distance equals the square root of, I'm going to say 0 minus a negative 3. So I went like this, 0 minus a negative 3, quantity squared, plus, and then I'm going to say, same direction, 10, so the difference of the y's, 10 minus 6 squared. So 0 minus a negative 3, 2 negatives is going to make that positive, so now we got 3 squared plus 10 minus 6 is 4 squared. And 3 squared is 9, 4 squared is 16. 9 plus 16 is 25. And the square root of 25 is 5. Once again, we're not worried about, we cannot use the negative sign because this is a distance, and distances will always be positive, right? Physical distances are always positive. Okay, let's take a look at number 5. Number 5, find the distance between these 2 points. All right. So I'm going to go in this oops, lost my pencil, this direction. Got to be careful of the double negative. So let me use a bracket here. We've got 2 minus a negative 2 squared plus, and then I've got 2 minus 2 quantity squared. So of course, a negative negative makes that positive. So this is going to ultimately be 2 plus 2 is 4 squared. 2 minus 2 is 0 squared. So we're basically just left with 4 squared, which is 16, and the square root of 16 is 4. So the distance between these 2 points, 2, 2 and negative 2, 2, is 4 units. And then let's take a look at number 6. Find the distance between these 2 points. Square root. Okay, let's go in this direction. Lost my pencil again. There we go, this direction. So this is going to be 10 minus a negative 4 squared plus, and then I'm going to go in the same direction, 0 minus a negative 7 quantity squared. Of course, double negative is going to make that addition, so 10 plus 4 is 14 squared. And there's a double negative again, so we have positive 7 squared. And it turns out that 14 squared is 196 plus 7 squared, which is 49. We add up 196 and 49, we get 245. And it says to please type the exact answer, so they don't want us to throw it in the calculator. Use radical symbols as needed to simplify your answer. So we need to see if we could simplify this answer. And of course, this is distance. I'll put the D there. We do need to see if we could simplify it. And if it's a perfect square, I don't believe it's a perfect square. But if I go over here and say 245 and start to factor it, it turns out that will factor down to 49 times 5. And so if we thought of this, okay, square root of 245 can be broken down using the product rule to the square root of 49 times the square root of 5. Wait, square root of 49 is 7. This is just 7 root 5. Oh, the distance is simplified down to 7 square root of 5. 7 square root of 5. Okay, number 7. Okay, so number 7, complete the following sentence. Now we're, instead of finding the distance between 2 points, we are finding the midpoint, the very middle point between 2 points. And so the way I think of this is I think of it as the average of the x's, comma, the average of the y's. That's how I remember it, and it always holds true for me, and I could easily remember it that way. So which one looks like averaging? Well, this one looks like averaging. The problem is you're averaging an x and a y. You don't want to do that. So this one is nice right here because you've got x from the first point plus x from the second point divided by 2. So that's being averaged. And y from the first point plus y from the second point divided by 2. That's being averaged. This is the answer right here. This is looking really good. Okay, so that is your formula. How do you find the midpoint between 2 points? You find the average of the x's, comma, average of the y's. That's how I think of it. Let me write that down. What is it? It's going to be the average of the x's, so x sub 1 plus x sub 2. How do you average two things divided by 2? Average of the y's, y sub 1 plus y sub 2 divided by 2. Find its average. All right, here we go. Got 2 points there. So if you want to find its midpoint, remember the midpoint's actually going to be a point, x comma y. So you take the average of the x's. Let's use a little color, I guess, just at the beginning. There are my x values, 2 plus 10. And the average, how do you find the average? Divide by how many elements that you're adding up. There are 2. And then, so the average of the x's, comma, the average of the y's. Y values, we have a 4 plus 10. How do you find the average of 2 elements? Divide by 2. So we've got 2 plus 10 is 12 divided by 2. That's my x value. And 4 and 10 is 14 divided by 2. That's my y value. I can simplify that further down to 12 divided by 2 is 6. 14 divided by 2 is 7. There's my midpoint between those 2 points. 6 comma 7. All right, let's do that again. Find the midpoint of the line segment joining these 2 points. The coordinates of the midpoint are, okay, well, no problem. Find the average of the x's. That's just going to be a negative 10 plus 8 divided by 2, comma, average of the y's. Negative 4 plus 8 divided by 2. Let's do the math. Negative 10 plus 8 is negative 2 divided by 2. There's your x value. Negative 4 plus 8 is positive 4 divided by 2. There's your y value. And the first x value simplified down is negative 1. The y value is 2. Negative 1 comma 2 is your midpoint between those 2 points. Let's take a look at number 10. Find the midpoint between 4 comma 1 and negative 3 comma negative 2. Put an M for midpoint there. The midpoint is going to be the average of the x's, so 4 plus a negative 3 over 2. Average of the y's, 1 plus a negative 2 over 2. And we simplify. 4 plus a negative 3 is 1, so we get 1/2 for our x value. 1 plus a negative 2 is negative, get my pen back, negative 1 over 2. So the midpoint is 1/2 comma negative 1/2. Next problem, number 11. We almost done? This went quick, didn't it? Finally a quick one. We got a break here. Find the average of the x's. So the x, so we're going to say 0 plus a negative 1 divided by 2. Find the average of the y's. Negative 3 plus a 3 divided by 2. So the first value the first value is x, so we've got a negative 1 over 2. And a negative 3 plus 3 is 0, and 0 divided by 2 is 0. So we're done. Answer is negative 1/2 comma 0. And that's our midpoint. And our last problem already. Here we go. Awesome. Last problem. Average of the x values. 5 root 5 plus 7 root 5. Find its average by dividing by 2. Average of the y's. Root 5 plus 6 root 5 divided by 2. Simplify. 5 root 5 plus 7 root 5. These are like radicals, so you could add them together. That's going to give us 12 root 5 divided by 2. And 1 root 5 plus 6 root 5 is 7 root 5 divided by 2. Okay, we have one more thing, one more simplification. 12 divided by 2, right? We're highlighting this right here. These are, these are factors. So you can reduce common factors, right? This is being multiplied. 12 divided by 2 is 6. So we've got 6 root 5 for the x value, comma, and then this does not reduce. So this is 7 root 5 over 2. And that is your midpoint. And that's it. So hope everybody's doing great, and we will see you, or talk to you, not see you, but talk to you soon. Take care. Bye.